learn about deductive argument. So now we are going to learn about inductive argument. So inductive argument, there are two we consider inductive argument, strong or weak. If strong argument, then the conclusion is true. If weak argument, then the conclusion is false. That means when we do a specific, right? So just now inductive argument, so it's from specific to general. So if the argument is the conclusion is false, that means our general conclusion that we form is false, then it is a weak inductive argument and not cogent. Okay, cogent. So if let's say the inductive argument, we have a general conclusion that is true, okay, so we call it a strong inductive argument. But whether it's cogent or not cogent, then it depends on the premises. If all the premises are true, then we can say that is a strong inductive argument and it is cogent. If all the premises are false or one of the premises are false, then it's not cogent, right? Cogent is everything is true lah. This is false, okay? Right? So, but to determine whether it's strong or weak argument, we are looking at the conclusion. If the conclusion is true, right, then it's strong. But the premises will determine whether it is a cogent or not cogent, right? If the conclusion is weak, is false, then it is a very weak inductive argument, right? So true or false of the conclusion will determine strong or weak. The premises, true or false, will determine is cogent and not cogent. If it is a weak inductive argument, therefore it is not a cogent because already false. The conclusion already false. That means we no need to determine whether the premises are false or true. Okay, so let's go through the examples. All right, so before that, inductive argument. So conclusion, true, so it's strong. Conclusion is false, is weak and not cogent. Strong inductive argument, IA, okay, strong doesn't mean it's cogent. Cogent must be everything true lah. The premises must be true, premises. Okay, if not cogent, so one of the premises is false. Okay, the premises. I don't think it's everything lah. So you can find one of the premises is false, then it's not cogent. Okay, let's see. Determine whether the given argument are strong or weak. Strong or weak. Hence, determine whether the strong argument is cogent or not cogent. So you can see from the question is already indicate that if weak, no need to determine whether it's cogent or not cogent. Right? If it's cogent or not cogent, you have to justify your answer. So, okay, let's see this argument. This is inductive. Remember, this is inductive argument. Okay, so later on I will ask you to sum up. So how to determine what is the criteria to determine deductive argument and inductive argument. So inductive argument, we are looking at strong or weak and cogent and not cogent. So deductive argument, what we are determine, valid, invalid, sound and unsound, right? So that is for deductive. Okay, so now inductive argument. The chairs in the living room are red. The chairs in the dining room are red. The chairs in the study room are red. The chairs in the bedroom are red. All the chairs in the house are red. So the conclusion, we're looking at the conclusion, true or false. So if we set The chairs in the living room, all red. Chairs in the dining room, all red. And the study room, all red. And the chairs in the bedroom, also red. So we conclude that the chairs in the house are red. So any corners of the house that we are not determining yet, bedroom, study room, dining room, living room, maybe right outside the house, we didn't determine. So we just said the chairs are, all the chairs are red. So it is weak and not cogent. So because we, the examples here or the premises here doesn't indicate all the corners of in the house. Okay, so it's only bedroom, study room, dining room, living room. How about kitchen? Okay, so this is weak and not cogent. Premise 1, 2, 3, and 4. So before that, look at conclusion. All prime numbers are divisible by 1 in itself. This is the definition for prime number. So this is true. So it is a true that is strong, right? Strong inductive argument. So strong. Is it cogent or not cogent? So you look at this. 5 is a prime number, true. 3 is a prime number, true. 2 is a prime number, true. 1 is a prime number, false. Therefore, it is a strong and not cogent. Strong because conclusion is true. Not cogent because of the first premise is false. Not cogent because premise 1 is false. Okay, 1 is not a prime number. So remember, 1 is not a prime number. Okay. C, premise 1, 27 is a multiple of 3. True? Okay, before that, we have to look at the conclusion. Sorry, conclusion first. All multiples of 9 are multiples of 3. All multiples of 9 are multiples of 3. So 9, you can divide by 3. 18 can divide by 3. 27 also divide by 3. So this is true. Okay, so it's strong. Cogent or not cogent? 27 is multiple of 3. 81 is multiple of 3. So both are true. So it is strong and cogent, right? Strong and cogent. Okay, cogent or cogent, gentleman, right? Pronounce gen, cogent, right? If cogent, then you tell me. Or, okay, premise 1, or a mackerel breathes on its grill. A shark breathes through its grill. Okay. Conclusion, all fishes breathe through gills. True or false? I don't know by your, right? But I think it's false. It's all the fishes through gills. I think ikan paus or whale doesn't breathe on the gills, right? Breathe on the lung. So it is a weak and cogent. So because this is false, the conclusion is false. So how about E? All multiples of 5 end with 0 and 5. This is definitely true. So it's a strong. Cogent or not? So 11 times 5, 55, true. 12 times 5 is also 60, true. So this is strong and cogent. Okay, so you do the exercise for science 1. Self-practice 3.2D, all the question on page 32. And 4C, you do the question in page question 27 and page 45 for book. All right? Okay, so this is about inductive argument. Weak or weak, not cogent, strong, cogent, strong, not cogent, right? So weak or strong depends on the conclusion, right? So inductive argument, again, strong because of the conclusion, right? Conclusion, right? So weak, this is a conclusion, true conclusion, conclusion false, weak. So weak will plus with not cogent. Strong will plus with cogent. if all the premises true. Right? All the premises or one of the premises is false. Okay, one of the premises is false, then it's not cogent. Okay, so that is to summarize the inductive argument: weak, strong, cogent, and not cogent. Right? So we go to the next one. All right, so this one is also a very famous SPM question. I mean, it's all usually or not usually asked, but did ask in SPM. Okay, so we want to form a inductive argument for each of the following numbers. That means we are going to form a general conclusion, right? General conclusion based on the specific conclusion. This is all specific, 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 specific. So what is the general conclusion? So this is always a 2 marks question, 2 marks question. Okay, so you can see here the sequence. Okay, visually we don't look at the sequence. This one you cancel out straight away. All right, so in the exam, cancel out. So we go to the specific examples. So again, we don't look at 1/1, this one only. So we look at the specific. You can see here, we list down 1 to the power negative 1, 2 to the power negative 1, 3 to the power negative 1, 4 to the power negative 1. So 1, 2, 3, 4 here is specific. So we want it to make it general. So we just substitute as n to the power negative 1. So what is our n? So n is specific one. Specific number is 1, 2, 3, 4. So 1, 2, 3, 4. And then you see here dot, 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 right? That means etc. So we also follow 1, 2, 3. So this one must be 3. Okay, so this is how you form a general conclusion. N to the power negative 1, n is 1, 2, 3, 4. The specific examples given, you change into a general statement, that is n. So usually we put n, we don't use x. So don't use x power negative 1. This one we don't use, we usually use n number, right? Okay, how about this? Sequence 0.5, so this one 0.5, 0.25, 0.125, 0.625 all came from this specific example. You can see 0.5 to the power 1, 0.5 to the power 2, 0.5 to the power 3, 0.5 to the power 4. So 0.5 is a constant. So 0.5 constant, we just copy. Just like negative 1 here repeated itself. So we just copy. So therefore we copy 0.5, right? And then 1, 2, 3, 4 is specific power. So we change into n. So what is our n? N is 1, 2, 3, 4, and so on. 1, 2, 3, 3 dots. Okay. So you want to put 4 dot, also no problem, but must be 3 and above. Dot, 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 dot. So remember this one. Okay, next. 1357 is generated by this example here on the right hand side. So cancel out here. So you can see 2 times 0 plus 1, 2 times 1 plus 1, 2 times 2 plus 1, 2 times 3 plus 1. So 2 and 1, 2 bracket plus 1 repeated. So we don't change anything. We change the numbers that it changed itself. That's 0, 1, 2, 3. So this one is n. Then the answer n equals to 0, 1, 2, 3, and so on. Okay. All right. So, okay. So this one is okay. So we can see sequence. This is term 1, term 2, term 3, term 4, right? So sometimes we can see here we don't start with 0 actually, but if you write 0 also accepted. So if you want to put n is starting with 1, 2, 3, 4, and so on, then our n here must be minus 1 plus 1. Right? So 2n minus 1 plus 1. So therefore, we have a new general form that is 2n minus 1, and then n is 1, 2, 3, 4, and so on. Okay, so but in this case, this is the, we just copy everything lah. Usually we just copy everything from here. We don't change anything because the n is given 0, 1, 2, 3. We just follow 0, 1, 2, 3. If you think we want to start with 1 also can, but the n here must minus 1. Okay, so both answer is accepted. Then the sequence is 0, 9, 24, 45. So you can see here. So this left side, we just throw it away. So the answer is 3 bracket n square minus 3, and n equals to 1, 2, 3, 4, and so on. Okay, so we say 3 dot, 3 dot. So it's already understood, must be, etc. means 3 dots. Okay, so this is how you form a strong inductive argument for number sequences. Okay, so this is the exercise for Science 1, self-practice 3.2e, all the question in page 83, plus the comprehensive practice, question 9 on page 89 to 90. And for 4C, you do question 28, page 45. Okay. Now we're going to problem solving. So this one is more to inductive argument. Okay, let's do. We want to form, given you a general form. Okay, general form, general statement. We want to find a specific conclusion, right? So you can see a regular polygon with n side has n side and n symmetry lines. Okay, so what conclusion can be made? The number of symmetry lines if a regular nonagon. So regular polygon with n sides with n symmetry. So what about nonagon? What is nonagon? Nonagon is segi 9 sisi. So 9 sisi, that means n equals to 9. So what is the conclusion? The number of symmetry lines for nonagon is 9. So you get full mark. Okay, so nonagon is full mark. Okay, 9. Okay, number 2, given the sum of the for sum of first and this one no first, odd numbers. Okay, first and odd numbers is n over 2 times 2 times 2n, 2n. So the n here means the first odd numbers, first odd numbers, first n odd numbers, sorry. So you can see here 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. What is the sum? So actually you can use calculator to find out, or you can use this formula. Okay, so but in this question you must use formula. So n, you need to find what is n. So what you do, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is 10. So we substitute in the formula 10 over 2, and then 2 times 10. So n over 2 is 5. So 5 times 20, you get 100. So if you don't believe, you can add 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 is 100. So let's check. Okay, so if you have a calculator, you just check, right? So whether the formula given is true or false. Okay. All right, so I'm doing it now. So it's correct, 100, right? So the answer is 100. So you need to show by using the formula. That means the question asks you to testing on the n here. What is n? So from here, you can count there are 10 n first odd number. So n is 10. Okay. Number 3. So this is signs, right? So given F equals MA, F is force, M is mass, A is the acceleration. Find what is the mass if force is 520 Newton with the acceleration 9.81 meter per second, right? So we use the formula F equals to MA. So we want to find what is M, mass, okay? So we substitute 520 for the force, and then M we don't know, but we know the acceleration 9.81. So what is M? M is 520 divided by 9.81. So you get 580 divided by 9.81. So you get 59.12, right? kg, right? 59.12 kg. Mass is kg, yeah? So the mass here is kg, right? Right. So this is number 3. Then number 4. So this one is all simple question. Huh? So it can be one part of the question, long question. So a numerical sequence is represented by the formula 3m squared plus 1. M is the number of terms. So M here is the number of terms. So what is the 10th term? So the 10th term means the M is 10. So we substitute in 3 times this. Sorry, this is okay. This is 1, huh? Okay, so this is number 1. So 3 times 10 square plus 1. So it's 300 plus 1. So 301. Okay, so then number 2, find the sum of the 5th term and the 8th term in this numerical sequence. Sum of the 5th term and the 8th term. So you want to find the 5th term. 5th term, the n is 5. So 3 times 5 square plus 1. What is the answer? And then n equals to 8. 3 times 8 square plus 1. What is the answer? Okay, then we add these two numbers. That is your answer. Okay, so 3 times 5 square plus 1. So it's 3 times 25. 3 times 25 plus 1. So you get 76. Okay, then 3 times 8 square plus 1. So you get 193. Therefore, the answer for 2 is the sum of the 5th term. So you're going for science 1, you're going to learn this. So we use T5 plus T8. So it's equivalent to 76 plus 193. So you get 269. Huh? The symbol for term. Huh? Term here is T. So T8, this one is T5. So add it together lah. What is the answer? Right? So this is question number 4, problem solving. Then question number 5. So given P plus Q, P minus Q can be expanded into P squared minus Q squared. So what is the conclusion can be made out of 3 squared minus K squared? So the conclusion here is we are going to show this, right? From here to here. So this means 3 squared minus K squared. So this is number 1. So you have 3 plus K, then 3 minus K. That is your answer, right? So what is conclusion? So state in the form of P plus Q, P minus Q, if P squared minus Q squared equals to 36, right? So how to, in the form, state in the form. So P squared minus 9 Q squared equal to 36. That means P plus Q, okay, P minus Q equals to 36. So what type of numbers can we get 36?